everyone. We are here with Dr. Samira Musa. How are you doing today?
I'm doing wonderful, Shanta. How are you?
I am doing well. My first question for you is tell us a little bit about yourself. Where are you from?
Oh, sure. So I'm originally from Ghana in West Africa. I was born and raised there. I only moved to the United States when I was in high school. And so I went to high school in New York City and did my undergraduate studies in upstate New York. Then moved to Wisconsin to do my PhD work. And finally moved here to Boston for postdoctoral work.
Oh, great.
Yes.
So, when you went to college, what was your major when you were in college?
Great question. So when I was okay, so when I first went to college, I had it in my mind that I was going to be majoring in computer science, and that was primarily influenced by my brother, one of my brothers who was into computers, and of course, as I like, I just saw how passionate he was about it, and I would learn a few things from him. So when I went to college, I thought I was going to do computer science, but I have to tell you, after my second or third computer science classes, I knew that I wasn't very excited about it. And, yeah, and I was like, oh no, I think I love using computers to do the things I need to do, but I don't think I want. Yeah, so it just didn't seem like but I think that realization came to me when I had to take chemistry as part of the requirement for computer science. And I found that I absolutely loved chemistry a lot more than computer science. So I knew right away that I wanted to major in chemistry. So I immediately changed my major to chemistry. Luckily for me, though, that happened very early on. This was pretty like second semester of my freshman year. So I knew early on that I didn't want to pursue computer science anymore. And I absolutely loved chemistry. And I really never regretted that decision to major in chemistry.
Ah, so did you go to graduate school for chemistry as well?
Correct. Yeah, I did go to graduate school for chemistry and organic chemistry lab actually. But perhaps what I think was really exciting about the lab I picked was that not only did they have chemistry background, but they also my graduate advisor actually had an appointment with chemistry and biochemistry. So a lot of my graduate work actually was at the interface of chemistry and biology, which really kind of broadened my horizon from undergraduate work being primarily focused on chemistry and really being able to kind of relate that in a biological sense for me was super exciting. So in a sense, my graduate work was a chemical biology experience.
So it seems like your mentor really kind of influenced your kind of career path, actually.
That is right. That is very, very true. And I think I find that when I pick mentors, I pick mentors who are doing things that I find really exciting. But I have to tell you, Shanta, one of the biggest things I learned, I think, from my graduate advisor was she always gave us this advice. I think when we are new and she says it, we kind of just like giggle and move on. But it's really true that the kind of training that she gave students, and I think that's how a lot of people should probably think about their careers in so many ways, is that she likes students to go where their ideas take them and not be limited by where their training left them. So if you think about it, I
Ah,
went to graduate school with a chemistry background, but I was able to not only do chemistry, but also do biology, right? So I wasn't limited by the fact that I majored in chemistry. I'm able to do it in a way that interface chemistry and biology. And I also kind of saw that progress in my in the lab I picked for my postdoctoral work. So my current lab uses a little bit of chemistry, but a lot of biology and also engineering. So in a sense,
wow.
I kind of started from chemistry, but progressively I've been involved in research projects that really work, function kind of at the interface of all these sciences. And I really think in a lot of ways that is probably the power of science. Science should really not be, it shouldn't have boundaries. So you have to be able to extend your training and your imagination beyond the, typical classroom courses that we take. Yeah.
So is it common to start out in like an area in chemistry and then find your way moving into biology and then also shifting again into engineering?
I think it's actually probably more common than we think about it. If you think about biology has so much to do with chemistry. Chemistry drives biology. And engineering principles uses a lot of chemical reactions. So if you, for example, major in chemistry, you are not limited by, say, being able to only synthesize compounds, but you can really think about how to use those compounds or materials that you synthesize to engineer some device that would be useful for a medical application. You can use the chemistry to develop some kind of platform that would be useful for addressing biological questions. So there's absolutely no reason to think that whatever you major in kind of puts you in a small little box. And you have to realize that in order for science to progress, we also have to kind of stretch our imagination and think of some of the things that people think are impossible. In order to do that, you really do have to step outside of that box and really do something different. And sometimes a lot of people draw inspiration from so many different places. I know my current advisor, for example, a lot of his concept of how cell biology works came from his art class. So he was in an art class, so a structure, and then he remembered seeing cells in his biology class behaving in a way that kind of reflected a lot of the artistic structures he was seeing in his art class. So, and that whole, realization actually developed this whole new area of mechanobiology, and I'm sure a lot of people have probably heard of that, but really that came about from people who really were coming from very different perspectives, not thinking like biologists per se or like chemists per se, but completely taking an art class, and he's using that art experience to solve biological problems. So I hope you kind of get a sense of where I'm trying to go with this, in the sense that your basic training does not really limit the extent that your imagination can go.
It sounds like this field, did you say it was mechanical biology? Is that the proper term for it?
Yeah, mechanobiology or mechanotransduction, which basically is a lot of like the way biological systems, for example, your cells respond to the physical structures of the environment. I mean, a lot of us understand cellular behavior from cell interacting with a specific molecule, right? But in many cases, not only are cells reacting to the molecule, but also reacting to the physics of the environment. So for example, if you think about your bone cells are exposed to very different environment, like your bone tissue is very rigid, right? And then you have a brain tissue, which is really, really soft. So the cells are not only recognizing the molecules in the tissues like the brain or the bone, but also the actual physical properties of the microenvironment. And it's now becoming very apparent that these mechanical features or physical properties, if you will, can dramatically affect cell fate decisions. So, so you can think about it like if we only thought about cell biology from a molecular standpoint, you would never be able to know that cells can actually sense the physics, the mechanical features of the environment.
So what is the meaning of this area that you're studying? How is it utilized in health, or what sort of functions does this research serve in our society?
I mean, so there's just a lot of emphasis. So if you think about in the medical field, for example, a lot of times we develop materials that could help patients when it comes to like implants, for example, or perhaps take a patient's cell type try to regenerate the cells or get the cells to behave in a functional way, in a way that the cells can be transplanted back into the patient, or allow for study in some kind of biological process that would lead to development of some kind of therapeutics. So if you think about it in this sense, say for example, you take bone cells from a patient and you put it in some kind of environment in vitro, which is outside of the patient's body. Oftentimes you want to mimic as closely as possible the environment that the cells were in vivo, in the patient's body, right?
Right.
As when you try to manipulate these cells in vitro, you really want to mimic the environment that they came from, so that they don't behave dramatically different if they were to be put back into the patient's body. So you would imagine that as you try to develop environments to maintain the cells outside of the patient's body, you would need to incorporate a lot of these features. That is, whatever environment or matrix or substrate you use needs to incorporate the molecular features, but also the mechanical properties. So if you're trying to culture bone cells, you would want a matrix that is quite rigid or stiff. If you want to maintain neurons or brain cells outside of the body, you would want an environment that's softer, because naturally they're exposed to very soft tissue in vivo. So you imagine that a lot of these changes in vitro can affect the function of the cells, which really can dramatically impact how we develop drugs or study human biology outside of the human body.
Oh, so the research that you do have applications in like pharmaceutical drug development, as well as maybe patients who need transplants.
A lot of medications or therapies that are developed for humans come from studies in animals.
This
And
is
it
true.
is exactly. So it is quite surprising, however, that like a huge percent, about 75% of drugs that work in animals don't translate well to humans. Clearly, because we have very different biology, right?
Yes.
So the idea, at least in my research, is that being able to develop these kind of environments that actually use human cells instead of animals or animal cells, we would be able to more closely mimic human biology, so that when we
Ah,
use these models to discover drugs, they would be more likely to behave in the same way when they get to humans than they would if we just discover it in animals, because we would never know if humans would respond the same way, which really is one of the key reasons why many drugs fail when they get to clinical trial, because the biology is just very different and you just cannot extrapolate results from animals to humans. So a lot of the effort from my work focuses on really trying to develop environments outside of human body that could mimic human tissue function, so that when we use these platforms to do a lot of these drug screening or even understanding how human biological processes work, we would be really close to finding something that's very useful, clinically relevant for humans.
well, see, I think this is really important research because when we talk about personalized medicine, being able to tailor treatments to specific patients based on such things like their genetics. And what you're talking about is being able to choose medications that will work better in the human body because it was actually developed within human cells.
Yeah, I mean, you're right, Shanta, and I think this idea is also really with the advancement with this induced pluripotent cell technology, which is the iPS cells. You often hear them as. We now have the capacity to very non-invasively take, say, human sample of human skin cells,
Uh-huh.
manipulate the cells in vitro that is outside the human body, so that they would go back to pluripotency. And pluripotency simply means that the cells have the capacity to grow indefinitely in culture, so that we can make more and more of them. But what's probably more remarkable about them is that they can now then differentiate into almost any tissue in the body. So
Wow.
imagine that you can take a patient's skin cells, in vitro eventually develop, say, heart cells
Wow.
or kidney cells that could, and then you would know that a lot of organ failures, for example, cardiac arrest, for example, results from failure in cells, right? Cells that are no longer functional. So in the long future, or hopefully near future, we hope that we could manipulate these cells in vitro outside of the human body and eventually transplant it to patients who might be suffering from damaged organs or tissues that are really resulting from cells not being functional. So imagine that replacing those cells could be a useful therapy for the patients.
Let's talk about how you've gotten to this point. Now, we
Sure.
know that you went to college in New York, right?
Correct.
So, how did you decide what college to go to? What was the deciding factors?
Okay. So of course I did. Like most people, I applied to quite a number of schools, and I think for me, so I moved from Ghana to New York City, which is I I have to say culturally and in so many ways very very different. So
Yes.
in a lot of ways, I was kind of craving for an environment that would be a little bit less crowded, a little bit calmer, because I thought that it would be very helpful for my academic development if I lived in an environment that just didn't have so much, that wasn't just so stressful. So I mean, although I applied for schools in New York City, I think I really was kind of leaning towards schools that would be um, outside of the city. And I thought it would be kind of a good way to experience a different
Environment.
environment, absolutely. But I think the most important factor absolutely was the school. The quality of the curriculum really influenced my decision hugely, actually. Yeah.
We go to college, we take a number of classes, I think 2 years of classes that are completely unrelated to our major before
Yeah.
we even get to the area that we wanted to study. Did you have a similar sort of experience as well?
Yeah, I think even if you have an area, so depending on your major, you might be able to immediately start taking courses within your major. But also, you also are required to take classes outside of for example, in my case, I mean, I went thinking that I was going to major in computer science, right? So I was taking computer science classes, and at the same time, I knew that I had to take chemistry, I had to take physics, and all these mathematics classes. So it was through that I realized that I really loved chemistry. So in a sense, it was a requirement for the computer science major I thought I was going to have, but then I really loved chemistry and then I switched. So in most cases, you would be taking courses from various departments, but chances are if you have a good sense of what you want to major in when you go, and your curriculum would be built around it so that you are not just taking classes that are only focused on that specific major. Yeah.
Now, a lot of people are really intimidated by chemistry. So, what helped you be so successful in a field that pretty much scares most people away?
Yeah, I think it's really being open-minded. I mean, I definitely, I'm very open-minded. I mean, I had definitely heard of people saying how hard chemistry was, and I went in not thinking it's hard because I was, well, if you don't know what it is, you never know if it's hard or not. And even if it's hard, it doesn't mean that you can't do it. I mean, to me, I really truly feel that a lot of times it's all about focus. If you really focus on what you need to accomplish, it's really hard for you to be distracted by unnecessary things. So in a lot of ways, it's just not going in with preconceived notions that this class is going to be impossible to excel in. So I feel like if you just approach a lot of classes with that kind of attitude and do the best that you can, really, I'm not sure that I've met anybody who's really given something the best that they can and didn't do well at. I mean, you can always decide that you don't love it, but as far as just doing well, you can do well in almost anything if you focus.
Did you have any sort of study tips or strategies that you used that was particularly helpful for you to do well in your chemistry classes?
Oh yeah, definitely. I think the one of the uh, most important is obviously go into classes and go into the lectures and
Yes, that is very important.
yeah, it's very, very important. And also taking advantage of office hours. A lot of times, some things may not be well explained, or you may not grasp everything from lectures because it's difficult, like listening to someone speak for an hour and actually being able to absorb everything they say can be challenging. So it's really nice to take advantage of the professor's office hours so that you can ask them specific questions that about things that probably weren't clear to you. And there are always teaching assistants. They usually have graduate students or postdoc students who would teach smaller. So if you have normally if you have a really big lecture class, you would be broken down into smaller. There will be smaller sections out of that huge lecture class that you can actually have a little bit more intimate discussion, if you would, with someone who would not typically be very knowledgeable about the area. And a lot there, you'd be surprised how many students don't really take advantage of that.
All
But it
right.
can really be one of the most important places for you to understand what's going on. Because sometimes the lecture in a huge lecture room, it can be intimidating to even ask questions for
This
some
is true.
people. So if you do take advantage of the office hours or the smaller discussion groups, is always very, very helpful. And then even getting to listen to what questions other people have could really help you, even if you don't have a particular question yourself. Just listening to what questions other people have and kind of understanding what answers are given for those could also really, really help you succeed. And like I said before, like it's really a matter of you have to focus. And that does not mean like being so intense all the time. Like, and just managing your time and knowing that, oh, maybe, and for me, I know I've known myself long enough to know that at a certain time of the day, I am very, very productive and I grasp things better than other times of the day. So
Yes.
once I figure that out, I reserve the time that I find that I'm very productive for studying. So yeah, so if that means maybe staying up later or just kind of just know what time works best for you and really take advantage of that because you cannot go around all day and then after like a really tired day expect to be able to just open up a textbook and actually pay attention and absorb everything. So I learned for me personally, I like to study really late at night or very, very early in the morning. And I'm sure different times work for different people, and it sometimes takes experimentation. But once you find that, you'd be surprised how helpful it will be. Yeah, and it makes you very efficient at grasping things or studying as well.
That's true.
Mhm.
Also, with you being from Ghana, did you find a lot of people at your university who you could relate to, that who you could have friendships with to help, deal with some of the stress of being in college?
Yeah, so yeah, I actually was quite surprised. I mean, in New York City, it probably wasn't too surprising to see that there were a lot of Ghanaians. But once I moved to upstate New York, it was quite refreshing to see that. I mean, there are people of different cultures who you can learn so much from. It doesn't have to be people who are exactly from your background. So no matter what school you are and what the demographics are, if you really open up and make friendships with people even from different cultures, you can learn really quite a lot. But I did find a lot of support from people who were Ghanaians or also Africans, and because in a lot of ways they would understand you from certain perspectives than maybe someone who doesn't have similar background as you. And so, for example, like, just being involved in student organizations and, having that social support was kind of nice. And I have to say, I actually met my fiance in college as well, who is also from Ghana. So Yeah, it's kind of,
Well, that was definitely nice, a nice bonus.
yeah.
I think that for a lot of international people, um, sometimes they come with accents, and having an accent or English being not their first language, it's a lot more difficult for them. But that seems like that was probably not an issue for you because you came to New York at quite a young age.
I think it's well. I mean, I do still have an accent, right? I mean, I've had accents since I've been here, so it's yeah. I totally understand what you're getting at, but I do agree that when you're younger, it's probably a little bit easier because you kind of have time to you probably learn things from you kind of learn from like a child's perspective in a sense that you can kind of blend in the culture or learn the culture probably or accept certain things a lot faster than someone who's probably more mature and have kind of their set boundaries, if you will. But I think in many ways, for me, I have to though say that in Ghana, English is the official language. So the language itself probably wasn't a dramatic change for me, but
Right.
definitely, accent wise and even English, of course, you learn British English in Ghana, and then I came here, and I remember one of the main challenge I had in high school, my first week in high school, probably the biggest thing I learned was how Americans write their date. Because I was writing day, month, and then year, and then it has here, it's like month, day, and then year. So
Right.
yeah, so it took me a good like couple of weeks to kind of get used to doing it that way. And I would always, like in an innocent way, ask why is this way? I mean, why can't I write it the other way? Or I would just explain why I think something makes more sense. It doesn't mean that I'm not open to understanding how other people think about things, but I try to reason or ask questions about why certain things have to be a certain way or yeah. like
So do you have any advice for people who come from other countries to this country on how to maybe get along with making that adjustment?
I think in a lot of ways, I feel like what an individual's ability to make these adjustments sometimes has a lot to do with their ability to accept who they are and really
Ah,
realize, you have to know who you are because if you are fighting that, it would be a lot more difficult to even understand other people or give other people a chance to kind of get to know you and that kind of thing. So I think and people are a lot more understanding than sometimes we give them credit for. So if there are many times when someone would ask a question that I would just think, well, that doesn't sound very smart. You would want to say that, but a lot of times it's just that the person might just simply not know. Just because you know it does not mean that they understand it. So it is always okay to, try to be kind to people and be open-minded. If someone is saying something that's incorrect, of course, as an African, there are a lot of things that I didn't even realize people thought about, Africa or thought Ghana was like. So in many cases, I would have to either correct people
right.
about certain things. And so it takes some patience because sometimes you just think that someone is just being silly, but they just really don't know. They don't know. And I'm sure if they knew better, they wouldn't say certain things. So.
But I also know that for you to be in a situation where you are a minority person and someone has a negative view about your country, it takes a lot of courage to speak up and explain to them that their point of view is not accurate or it doesn't reflect the majority of people. There's a lot of internal strength that is required to do that.
Yeah, yeah, I think that is it does take, especially if you're in an environment where, like you said, you find yourself being sometimes you feel like you're like the only African American in the whole town, and sometimes you get to a point where you just feel like that's what other people think, and you may not feel like it's your place to correct them or anything like that. But I really think it is okay, because if they're brave, or I'm not sure if bravery is the correct word, but like if if they actually had the courage to say something that is so incorrect or inappropriate, you should have no shame in correcting them. Yeah.
Absolutely. And I think, when you're in situations like that, it's how you do it, you know?
Absolutely. That's definitely one of the things I was thinking about, but kind of forgot to mention. It has to do with how you do it, probably more than anything else. Yeah, definitely do that. Like
Particularly,
how you do it. Just because someone comes across sounding like a an ignorant does not mean you have to talk back to them the same way. And you'd be surprised, like if you really genuinely like respond to someone in a very graceful way and make them understand that you're what they think is not the case, and you try to correct them, you know you'd be surprised. Sometimes, a lot of times, people will be very, very receptive to that, or it would just kind of turn that light up that maybe was dim in their head. I mean, and the next time they think about saying certain things, they would really make sure that they have their facts right.
this is true.
Yeah.
So you completed college with a chemistry degree. You got a bachelor's degree in chemistry. And
Mm-hmm.
so when did you, or how did you decide that that wasn't enough, that you got to take it a step further?
Okay. Um, so like I said before, I once I got into chemistry, I really, really loved it. And then I happened to, I remember the summer before my actual freshman year. So I visited my then future college, and then someone gave a talk about careers beyond, or like careers beyond beyond undergraduate work. And I remember them talking about what graduate school was, and some of the reasons why people might choose to pursue graduate work or so. And so and then there was this program called the McNair Scholars Program, which is
Yes.
an excellent program. For me, that was definitely one of the best programs I've ever been part of. So as an undergraduate, I got involved in the McNair Scholars Program, which allowed me to pursue independent research studies in the laboratory of a professor of my choosing. For the most part, I mean, you choose, it's a mutual thing. You choose, and if the professor really wants to work with you or take you into their lab, they accept you, and then you get to work with them. So in my sophomore year in college, I got to work in a laboratory, and I absolutely loved it. I loved my undergraduate advisor then, and she was absolutely amazing. I learned so much. It was just not just science, but I think a lot of the inspiration for me to pursue graduate work really came from her. And I think my experience in her lab really solidified my decision to pursue graduate work. And once I found that I absolutely loved chemistry, and I realized that the potential of just being able to answer questions that nobody has answers for became like a passion of mine. And really the way to do it is not just go into the classroom and reading what's in the textbook. Things that are in the textbook are already known, right? So
Right.
anybody can learn those things, which is great. But after you've learned those things, it's always nice to be able to produce new ideas, solve problems that don't have solutions. And so that's kind of how I really got inspired to continue in the scientific research program, and then I applied for graduate school, of course, and I really, really am glad that I did, because I absolutely really, really love the fields that I've been in.
So what was that process for you of choosing a graduate program to start your studies?
Yeah. So actually, the McNair program also, in addition to allowing students um, to perform these independent research work in the laboratory, kind of gives a lot of guidance to students on how to apply for graduate school. So I have to say that I am a first generation college student in my family. So there weren't a lot of people above me that had tremendous experience, especially applying for college or I mean, for graduate school here, especially in the United
Oh,
States. So I
yeah.
have to rely a lot. I mean, my family, I have to make sure this is really clear. My family is extremely supportive. But when it comes to actual specifics of how to, apply to graduate school, I relied a lot on outside sources, even reading books on how to do that, and making sure that I got feedback from other people. Like, say, my undergraduate advisor, I got, when I wrote my essays or completed applications, I made sure I got feedback from people. I even asked them what materials could be helpful to include in my application material that may not necessarily have been asked for, but could probably help my chances of getting in the program. So things like that. And I find that it's incredibly helpful to have people there are so many people who will be very willing to help, but in many ways you have to ask. And once you ask, you'd be surprised how much people would be really willing to really support you and help you. Yeah.
So it seems that if you don't have people immediately available to help you with these graduate applications, turning to your advisor in college will be a good source. Also, getting involved with the McNair Scholars Program will be a good source. Can you think of maybe any other sources that people can turn to at the university level to get help with this process? Because it is really difficult and it's expensive.
Oh yeah, that is absolutely true. It is challenging. I think it's challenging no matter what your background is, really. And many times the application process can even change so dramatically from year to year, and the requirements and the competition levels change depending on which school you're applying to. But I have to say that it's not just programs like McNair Pro, but a lot of the academic career centers in most schools, even at high school level or in college, a lot of them would offer a lot of assistance with these kind of processes. So like I said before, some of these services would be advertised and some would not be advertised. So you would have to really be proactive about searching online for what is available or who on your campuses would be able to help you with it. And even sometimes asking your professors, because a lot of professors would have students who have already
Ah.
applied to school, so they really do know the process. And so really, really take advantage of your professors. It's not just simply going to class and learning the official materials from them, but sometimes they're very, very willing to help you with other things in terms of advancing your career. So, and they will offer, because a lot of times professors sit on the admission committee, of course, so
Ah, this is true.
they know what kind of things they're looking for in admitting for the candidates that they admit. They always know what stands out to them and what kind of things they look for in the applications. So professors are definitely an excellent source. And of course, it's also helpful to talk to students who've already applied. And I'm always happy to talk to students about applying for either from college or graduate programs, or even finding summer research opportunities and those kind of things. So definitely, I'm very happy to help if anyone wants to reach out.
So you went to graduate school, you have a master's degree, and you also have a PhD.
Yeah, so I actually went into a PhD program straight from undergraduate.
So, I would like to know what is the difference between a program where you have to do a terminal master's or do a complete master's first before you apply for a PhD?
Oh, good question. So, a lot of programs would allow you to either apply specifically to the master's program or to a PhD program. And in the way the PhD program is designed is that in many cases you get into a PhD program, but really what you're doing is you're going to complete the master's part and then do your component that really earns you the PhD. So as you can kind of tell from that definition, the master's program is typically shorter, about a year or two, depending on your area of choice. Especially in chemistry, I know it's typically about 2 years. And for a PhD could range from an average of 5.5 years or more. So, and a lot of times, your first 2 years, which is during the master's period, a lot of it involves taking additional courses that are more specialized in your field. And so within that 2 years, you take a lot of courses, and sometimes you will be required to do a little bit some research, independent research work. And for example, in chemistry, that would involve actually working in a laboratory on a specific project in addition to taking all the classes. And your advisor, along with your committee members, so typically you would have a committee of professors who would guide you through the process and all evaluate you at each stage of your academic career, and they would approve whether you're ready to have your master's or your PhD. So for the PhD, I think a lot of the years in during the program is really spent towards developing a specific research platform. So you will have a specific research question you want to address and do a lot of experimentation to answer that question. And of course, you start off by proposing a hypothesis, and of course, things can change. It doesn't have to be the same. Your hypothesis doesn't have to be true or align exactly the way you thought of it. But really, the idea is to produce new knowledge. Right. So think about it as an undergraduate. A lot of the things you learn, you're basically consuming knowledge. So as a PhD, you're expected to know what is there already, but also produce new set of knowledge that, or in a sense, answer questions that solve problems or answer questions that nobody else has answers for. Yeah.
All right. Yeah. So it seems like getting a PhD in chemistry is a very long process.
I mean, it is quite a commitment, but I think if you're passionate about something and you really know where you're going, it doesn't really, it wouldn't matter too much because it would be so worth it once you have it. I think no matter what so for some, I know not every, if you know what career path you want to take, for example, you may not need a PhD. I'm not saying don't go get a PhD, but it's just that you may not need a PhD for the career you envision. Sometimes masters might be just sufficient, but certainly if getting a PhD could really advance your career, it really does not hurt at all. Because I think if it takes 2 years to do masters and additional 3 years to get a PhD, it's in the grand scheme of things, it's not that bad.
So if you, let's say for example, you decide that you want to get a master's in chemistry, what sort of career opportunities are available just for folks who get a master's degree versus people who decide to take that extra step and get that PhD in chemistry?
Oh, I see. So a lot of, so at the master's level, a lot of master's students in chemistry, and this is also true for a lot of the sciences like biology, biochemistry, or genetics. A lot of them would, can actually have teaching positions if they choose to, but probably majority would have industrial jobs, like say work for a biotechnology company, for example, or a pharmaceutical company. And actually a large portion of scientists also become patent lawyers. So
Oh.
people probably don't think about it, but if you want to be a lawyer defending the next big drug that comes for curing a certain disease, you have to understand the science behind certain things. So a lot of scientists also get into law, and there are definitely a lot of people involved when it comes to the laws protecting the uh, a lot of the scientific breakthroughs. So there's definitely a lot of opportunities out there for people with masters. And some undergraduate students actually can also eventually get to these routes as well. For a PhD, a lot of PhDs, one probably the most popular academic route is to have an academic or an independent research career that is a professor at a research university, and that could be at a university that is mainly uh, like uh, like primarily undergraduate, or it could be a research one institute, or a larger university that focuses mainly on research. And so that the professor would have a lot of their focus would be on doing research and a lot of these scientific development. And also, in order for if you want a higher position in a biotechnology, for example, be a senior scientist or be the director of operations for a specific division, having a PhD is a very good way to get to that kind of high level jobs. And actually going back to the question about is it worth it? Maybe taking that additional few years to get that PhD. Sometimes it would take you a lot longer to get to that higher position in biotechnology if all you have is the undergraduate degree or the master's degree. But with a PhD, you can really get there a lot faster. Even including, even if you include the number of years it took you to get a PhD, it could still be a faster way to get there. And again, a lot of PhDs could also get into patent law as well. And there's also a lot of teaching. A lot of people go into teaching, as I've mentioned before, actually. So there are actually quite a lot of opportunities out there, and a lot of people actually spin out and develop their own companies. So
Ah.
yeah, I mean, there are a lot of some. Most people probably start as professors, where they have probably one of the most attractive thing about being a scientific professor or a researcher is being able to actually work on problems that interest you. So, and a lot of the breakthroughs from these research can lead to development of a biotechnology company. And so there are a lot of professors who end up building their own company. And another option is, as a scientist, whether with a PhD or a master's, they can go into forensic science, for example. So I know there are a lot of chemists, and a lot of the people solving a lot of these crime problems are actually chemists and biochemists, so and biologists. So that's definitely one other option for people who might be interested in law, but in a different way from a scientific point of view.
So are you talking about people who function on these shows like CSI that are super popular now? These guys in real life, not the actors on TV, but in real life, have a chemistry background?
Absolutely, and most of them are scientists. Yeah, so definitely that's definitely one of the probably I think everyone I know who goes into that field thinks is absolutely like is the coolest thing on the planet. So
Well, it looks cool on TV, I tell you that.
yeah, coolest on TV and on Earth. Yeah, but yeah, it seems like a really exciting opportunity as well for scientists. Yeah.
Now, you mentioned a couple of job opportunities for people who go into chemistry, such as also going into law.
Mm-hmm.
And I know that if you have a degree in science and you want to go into law, you do have to go to law school as well. So I want to make sure to mention that for our viewers, that they can't just finish their master's degree and then go into law. They got to go apply to law school. That's another 3 years in law school. So that's
That's true. That is true. And I believe there's there's specific dedicated fields for, say, patent law, for example, that may not necessarily follow the traditional
ah.
law route too. Yeah, but of course, people who might be interested in would have to look into that.
And another really exciting opportunity too would be to start your own company. One thing I do know that as a scientist, if
Mm-hmm.
you are working in a university setting and you develop something or create something new, you
Mm-hmm.
don't actually own it, because if you're doing work at the university actually owns all the work that you do. That's another point that most people don't know.
Mm. Yeah. So that is correct.
You didn't just stop at a PhD. You're also a postdoctoral fellow as well.
Yes.
So, how did you make that decision to not stop training, but to continue to train further?
Yeah, I mean, definitely one of my career goal is to become an independent research scientist at a university in a university setting. So one typically after a PhD, it is expected that you would do a short postdoctoral work, which typically is shorter. It could be anything from a year to about 4 years, depending on the lab, before transition into to having a professor position at a university. So that really is primarily the reason why I pursued postdoctoral work, and it gives you the time also and opportunity to really refine your own personal research direction. Because in order to have a very successful independent career, you have to be able to distinguish yourself from your own mentors, from your graduate work and your postdoctoral work even. So during the postdoctoral period, it really gives you time to refine who you want to be as an academic.
What are some of the things that you definitely want to talk to your mentors about? And what are some of the things that maybe necessarily you don't really need to be talking to your mentors about?
Okay, well, so I think that is actually a really great question. So this is why it's important to have multiple mentors. So you
Okay.
can have mentors who you primarily share personal issues with, or you can ask their feedback on personal issues. And then you have for me, for example, for my PhD advisor, I'm probably not gonna talk about my personal issues with, because I wanted to be very scientific and just that professional relationship. So most of the time it would just be scientific. And when I was applying for postdocs, for example, I looked up professors that I would really like to work with, and then I asked my advisor what did they think about a lot of these professors, and they may know a lot of times they know these people. Going to them and really asking them that kind of question is good. But like I said before, you don't have to have one person that you go to for personal or professional issues. You could have a peer mentor. It could be someone
Yes.
just your age group who could understand you from a different point of view. So so your best friend could be a peer mentor, if you would, and you can always ask, just kind of discuss things with people. And
Okay, I got one final question for you. And it's really around what are some tips that you have for choosing a good mentor? Now, not someone who you know really well, you've seen them around, you know stuff about them. I'm not talking about that. I'm talking about brand new folks who you want to work with either in a lab or you want to ask them to be your mentor.
sure. So the way that I picked mentors in the past, I say now, but throughout my scientific career, has really been getting to interview with that person. So when I go in for an interview, I don't think of it as they're interviewing me only. I also feel like I'm interviewing them. I have to see qualities that I know I could really benefit from. I like to have a mentor who I really look up to, that I respect, but someone that I really feel genuinely cares about my interests as well. Someone I can trust that would help me get where I need to go. And and sometimes it takes some courage, but you can ask the person specific questions if you're not sure, especially if it's someone you don't really know very well or not too long. It is okay to get to talk to the person multiple times before deciding if you want to work with them. In talking to their students, it's an excellent way to learn about how the potential mentor actually relates to their students, what their students think about them, and if or not their students are happy.
Now, do you find that students are honest when you ask them about their mentor?
Absolutely. Just make sure the mentor is not there when you ask them.
Okay.
But if you talk to like at least 3 people from their lab, chances are you would always get the right answers. And I think I've been in situations where they were so honest that I could not believe that any of the things they were saying were true. I mean, and I would laugh because I thought it was a joke, but then I realized it's actually true.
Mm.
Yeah, and especially students, because a lot of students don't really want other people to be in their situation, especially if they're unhappy. They wouldn't want other students to be in their situation.
This is true.
So a lot of times they would make sure that they tell you the absolute truth. And if someone did not tell them the truth, it would most likely be, if they didn't know the truth before they joined the group, it will most likely be because they didn't ask. It's okay to ask very specific questions. Like when I go into interview with professors, for example, I ask the professors, first of all, just, you ask them, of course, you would already know about their science before you go in. You can ask them questions about how they do their science, how they approach it, what are their expectations of their students, how do they measure their students' successes, and how do they mentor their students. And you ask them, what is their mentoring style like? And a lot of times when you ask the professors these questions, and ask their students, you can see if there's a disconnect. Usually there's a disconnection between what the professor's expectations are and what the students think the professor's expectations are. It tells you that the professor is not good at communicating expectations to their students. And if a professor tells you that, their students are happy, they're the best professors, whatever, and you talk to the students and they seem very unhappy, obviously you know that they're not, either they're not being honest with you, or they're just trying to really get you into their lab so bad that they feel like they didn't have to tell you the truth. But oftentimes I find that if you really ask specific questions, you always get the right answer. I remember my undergraduate advisor, when I asked her, what are your expectations for your students? How frequently are you around? She told me, she said, I expect my students to be independent. I'm not going to be around a lot because she travels all the time. She's gone a lot. But when she's around, you have to come find her when you need her because you may not see her all the time. And that may sound very intimidating, but for me, it was actually quite, I liked to hear that, and I felt like she was honest. So when I joined the lab, I knew that she wasn't going to be around all the time, and I was okay with it. Mm-hmm. Some may not. We have people who didn't want to join our lab because our advisor was not around a lot, and those students felt like they needed that kind of. They needed the advisor to be around a lot. So it's always good to know what your expectations are. You have to know how you work. If you're someone who's very independent, can grasp things on their own, or learn from people around you, and not only the big person, but you
Right.
learn from people around you. You know that you have that kind of energy and independence, and you may not be intimidated by your advisor not being physically present all the time, but of course you want an advisor who would be very responsive to you. Some professors would not be around much, but if you send them an email that you need them, they would make sure that they arrange for you to meet them. So ask the students. There are some professors who are not around a lot, but they would never respond to your emails either. So you want to make sure that that is not the case, because there's one thing between being independent and actually having your advisor also be there when you actually do need them. They have to really show that they care. And that's important whether you are super independent or not, because you can do all the work, but at the end of the day, you need their lesson, or when you need to publish a paper, it has to go through them. So if they're never around or responsive to you, then that creates a problem. And it's always nice to pay attention to the kind of culture that the advisor builds in their lab. So in some labs, I know that their professors really live by example. If they, especially if you go into a very environment that's very multicultural, some professors make sure that they respect each member of the group's culture, and they would celebrate holidays even if they don't practice whatever holiday it is with the group. If that kind of cultural experience is important to you, you can ask students how do they embrace other people's culture. Do they even do anything together? Those kind of things. So I think in a lot of ways, when you know yourself, you would know what you know what you need, and make sure that you communicate that very well. Don't, when you, like I said before, when you go on interviews, also interview them. Don't feel like you are the person that is, just they don't have to ask all the questions. It's okay for you to ask them the questions. Yeah.
So another important thing, as well as ethnic minorities, is making sure that you work with advisors and mentors who feel comfortable and have experience working with other minorities.
Yeah, that is true. So yeah, that's very important. And I think you can get a sense of that when you talk, when you have one-on-one talks with these professors. I mean, they may not have experience mentoring a minority student, but they often have to start from somewhere. It is okay if you are the person you need to start with, but I think you have to feel comfortable and trust that this person would have your best interests, in mind, and they will be willing to really help you and understand you, and not, kind of just avoid talking about race issues, or if it does come up.
Well, Dr. Musah, I really appreciate all of your time and all of the wisdom that you have shared with us today. Is there any final thoughts that you want to leave us with before we close out the program?
Oh, sure. Thank you, Shanta. It's been great speaking with you. And I really do wish every student who's watching this episode the absolute best luck. And really, I think one of the biggest lessons that I've learned, I think I mentioned this earlier in this interview, is that be open to possibilities. Don't limit, and don't limit yourself, and definitely don't let one person tell you that you cannot do certain things stop you from trying, or really going for what you really are passionate about.
Absolutely. Well, thank you so much, and take care.
Sure.
Okay.
Bye.